Hey everyone, welcome back to Zero's Ham Shack. Today is Wednesday, September 10, 2025, and I have, at this point in the game, accomplished all of the electrical changes inside the linear amplifier that need to be made. Got my schematic diagram here. I don't know how well you'll be able to see that. It is all marked up with circles and arrows and a paragraph on the back of each one explaining what each one is. For those of you who get the reference, that's Alice's Restaurant. I did run into one mishap, well, more than one, but one in particular. In the process of wiring it up, I ended up damaging the coil of the 110 volt 3-pole double throw relay inside the linear amplifier. I thought about just changing the whole thing out and making it 12 volts, but that affects so many other circuits within the amplifier that I decided to stay the course, add the secondary keying relay, and order a replacement 110 volt DC 3-pole double throw relay to put back in here and finish up the electrical part of the modification. What I will tell you at this point is this upgrade or this modification is not for the faint at heart. If you have all of the parts in hand in advance before starting anything, you've got your transformer, you've got your voltage regulators, you've got your new resistors, you've got your tube, you've got all the stuff, everything that you need, your finger stock, everything that you need to make this thing all laid out on a bench. You are still looking at, conservatively, 2 solid weeks of concerted effort. And I'm talking 12-hour days or 10-hour days, okay, of tracing wiring out between the various versions of the schematic diagram. So this is the old schematic diagram, this is the new schematic diagram, and making your comparisons, making sure you don't pull out wires that you shouldn't pull out, and rerouting them to the places that they now need to go, yada yada yada. Takes a lot of time, and again, this is not for the faint at heart. If you want to try this upgrade and you believe that there is any chance that you might not finish, don't start. That's my piece of advice for you today. If you don't think you can do it, don't. If you do think you can do it, I'm going to give you everything that you possibly need that will hopefully make that process as easy as possible. I've already done one. And I know where the pitfalls are. Even still, 2 weeks. Easily 2 weeks. Okay? So that's my piece of advice on this for now. And the last step for me before installing the new relay is to get started on the heatsink. And for that, I don't know if I showed you this already, but this came on eBay. Seems not eBay, came from Amazon. Seems to be pretty decent quality. It's a 3.5 amp oscillating multi-tool. Most of them are like an amp and a half, 2.2 amps. This is 3.5 amps, 400 watts. Pretty beefy. A 4-inch oscillating angle, or 4-degree oscillating angle versus 3.2 or 3 of most of the others. And a set of diamond blades to do the cutting on the heatsink as well as the window on the back. So I'm pretty excited, pretty pumped. I'm going to start using this now and open up the window. So the sequence of events now to get the heatsink mounted And to get the new holes on the heatsink in the proper location, the sequence of events is open up the window at the back of the chassis first. Put the heatsink back in place in its original location. Put the new tube into the socket and measure how far the center post is to the heatsink. Drill a hole in the 1/4 inch block, accounting for the thickness of the shim that presses against the heatsink, like that, right? And the 1/4 inch beryllium block. So I'll put those pieces in place and measure how far the post is from that. And that will allow me to drill the hole in the copper block, a little bit oversized for the stud on the top of the tube, so that there's a little bit of play for it to shift around before I tighten it into its final position. Well, we'll be showing you that later, but that is the sequence of events. Once I have that, then I can also mark the back of the chassis and measure how far up the chassis the new holes need to be located. That will also give me the difference on the hole location on the heatsink, and I'll know about where I need to cut the fins out to drill the new holes to match the new location at the back of the chassis. Once that's done, everything can go back together. All the heatsink compound can get assembled, the beryllium oxide insulator, the clamp, all that good stuff. So should be fun, and let's get going. And true to form, Numbnuts over here cut out the window, did all the measurements, showed everybody how that's done, didn't hit the record button. So we're going to give you the abridged version now, all right? Sorry. But hopefully you'll get enough out of it to recreate the steps that I just went through and showed everybody, but didn't really. Anyhow, step number 1, pull the tube out of the tube socket and remove the top section of the tube socket for the grid. Put a piece of duct tape over the cathode section to keep all of the tiny particles out of it, and then use the oscillating multi-tool. This is the blade I ended up using. I think it's 18 teeth per inch, maybe 24 teeth per inch, something like that. I was able to very quickly go slice right up through the soft aluminum on both sides and then just break it free, deburr it, and was done with that. I started trying to use the diamond blade cut, and the material is too soft for the diamond blade. The material on the heatsink I don't think will be too soft, so I'm still going to use the diamond blade to cut the fins on the heatsink. But anyhow, after cutting the window, I reassembled the tube socket back together and then put the tube in the socket. And with the tube in the socket, I took the 1/2 inch copper block that is going to sit on top of the tube and held it against the back of the back of the chassis. Took a pencil and scribed a line across the back of the chassis at the top of the copper block, and then subtract, because the copper block is 1/2 inch, I subtracted 1/4 inch, and that is the height that I needed for the new holes for the clamps for this copper block, provide the heat sink for the tube. Using my tape measure, I measured how far down from the top edge the line was that I drew inside the chassis, and it was 1 13/16 So if I added another 1/4 of an inch to that, that became 2 1/16, which would put me at the center of the copper block for the clamp. On the back side, got out my square. Set the square to 2 1/16 inches from the edge, minus the thickness of the pencil tip. I'll demonstrate here. Just like that. That's 2 1/16 minus the pencil width. Took the square, held it against the chassis, scribed my horizontal lines on the back of the chassis in both spots above the original holes, and then extended the square down so that it overlapped the lower hole, centered it over the lower hole, draw my vertical lines above the lower holes, center punch, and then drill them out at 3/16. That's the abridged version. I'm about to, and you probably appreciate that anyway, because the other one took a lot longer. I'm about to now start working on the heatsink. And I know after measuring these holes that the holes are 2 1/4 inches apart horizontally, and the new holes, like the old one, like the first amplifier I did, the new holes are 1 1/4 inch above the existing holes. Now that number will be different for everybody depending on variations in your tube socket and how high the tube actually sits inside the cabinet. So don't take that 1 1/4 to be gospel, because it's not. If you make your tube socket a little shorter, let's say you use a 5/8 inch standoffs instead of 3/4 inch standoffs, which is entirely doable, that's going to shift everything down by 1/8 of an inch. And so it would be either between 1 1/4 or 1 1/8, depending on the thickness of your standoffs when you make your tube socket. And how you assemble the finger stock will also affect how high the tube rests in the whole tube socket assembly. So that's that. Now let's get to work on the heatsink.